Hello everyone, I wanted to provide you with a video with some examples of the plugin working. It works the same on Unreal 5 as it does with 4.26 and 4.27, so let's just jump right into it. First we have the plugins. We have to make sure that it's enabled because otherwise the nodes don't exist and the project settings entry doesn't exist, so let's go check that project settings entry. Scroll all the way down to plugins, check save game settings, and here we have our settings. So this has to be set. If this is none, the system just won't work because it uses the the engine system internally for saving and loading to slots. So it needs a save game object. And you can either have a save file name for single file saving, or you can omit this for multi-file saving, and the file name will be the save slot name. Let's just put this back. And then we have multi-threaded saving as an option, and then multi-threaded events. And I'll get into that a little bit later. And automatic actor saving says every time the game is saved, it collects every actor in the game, in the world, and stores them. And they can be spawned by using the spawn stored actors node. So let's go ahead and go into the menu. So we have our main menu, and it's got some buttons. So we start by um, making sure that there are save slots that exist. There's another function that can handle this called do save slots exist, but I ended up doing this just sort of arbitrarily. And I am updating the save slots based on the provided names. So I created a save slot widget, so let's take a look at that. The save slot widget just says the name of the slot, the date that's created, the time that has been played in seconds, and it actually calculates seconds, minutes, up to years. Um, and you can delete the save, and it removes this entry from the list, which I'll show you later. But um, the internal functionality of this button is pretty simple. Let's take a look at update first. It receives the save slot name and the save slot info, which I will actually show you. Let's see, update slot. So we go through, we create the save slot widget, we add it as a child to the save slot box, which is a scroll box here, and then we update that created widget with the provided slot name, which I'm just getting save slot name of that slot and telling that specific widget save slot object to update, which is this. Um, and I'm setting the active save slot here, which I'm realizing is not necessary, but it's sort of here it sort of doesn't matter. Um, if the slot is uh, not empty, then set all the information. If it is empty, then the delete button should not exist, and the time played and date created don't need to be shown, so we collapse those. And in the event graph, I'm just grabbing the player here for convenience because it owns the HUD, which I need to hide when a save slot button is clicked, because that means we're trying to load the slot. And um, it receives the save slot name here on update, so that on load game, it just plugs that in, and same with delete. And I just added a little extra functionality here, so that way if delete game is successful, we remove that slot from the parent, regardless of what happens. But if there are no more slots left, then uh, get parent set. If there are no more slots left, uh, we want to get back to the main menu. So in save slot name, when you create a new game button, it makes save slot name visible, and save slot name is just a little extra stuff. Um, when you click the back button, the slot name widget is hidden, which I'll demonstrate all this. And then we reset this so that way when we go back to create a new game, it doesn't have text still. And then on the confirm button, uh, we when the text is edited, we save that, and then I'm doing a bunch of extra stuff here for verify entered name. This just checks the length. If there is no text, we just disable it, otherwise enable it. Do a bunch of extra work to call any invalid characters to prevent the player from entering invalid characters that affect file path logic, which I'll show you real quick. I'm not going to get into this, but I'll show it in the video just so you have it. So if you want to do all of this, then go ahead and pause. And when we successfully create a new save game, we want to save it. Um, I'm not doing this internally because I want to give you control over how things are saved. So I am just, for this demonstration, I'm just saying, okay, once the new save is created, just save it so we have that slot in the file and the file is created. Then the save slot name widget needs to be hidden, and so does the HUD. Um, and so let's go to our character. Pretty simple. I tried not to do too much. Begin play, just create the menu. And the menu is what I showed you earlier. It's just the menu container that contains the buttons, and then save slot select and save slot name, just all in one convenient spot. So it can be handled easily through this. And then I'm using events uh, for post load and save created. So on new save created, I store an example struct and then save the game so that way that data gets saved. And apparently I forgot this. So on post load, we get any stored values. Actually, let's go over here. So this is my little example. So when you press 1, it increments some variable that's then stored, and then it spawns a sphere. Sphere is very basic. I'll show you that as well. And then the sphere is stored, so that way we can return to that game state on load. On save game, we store the transform of the player, and then update the existing save. This ensures that we update whatever save is currently active. On post load, we load it. We get the stored transform for the player and then teleport the player to that location. Then we spawn stored actors. And here's a bunch of extra work. So since this is a wildcard node, it can receive any value, and I'm plugging a struct into it for demonstration purposes. So we have to do a lot of extra work to get that data because of how I have to get the data internally to store it. So we get the object name and append that to the name of the variable. Then we get any variable names within the struct. So in this case, my boolean, my int, my transform, and I'll show you the struct real quick. A bunch of example values. I specified spaces versus not spaces here just for demonstration purposes to show you that you have options. And so we just get those values for primitive values like booleans and integers. We can just straight up get the stored values and then plug them right in. But for structures, we have to get the values for the inner struct. And then once we have the values for the inner struct, we have to get the variables from within that struct. So in this case, transform vector, vector has x, y, and z. translation has X, Y, and Z, rotation has X, Y, and Z, and scale has X, Y, and Z. So we get all those values, and then we recreate the transform, and then just plug that right in. And then the float array is very similar. We take the name of the struct plus the object name, and then add the name of the variable within the struct. And there's two ways of doing this. One way is you can individually get the indexes and specifically specify how you get those and store those. For simplicity, I created this function that's just the array size, and we append the array size to the label, so that way we can get the value stored at that array index. And I am storing all of this data in a local uh, float array, so that way I can just output that, and that gets outputted into this, and then this is where it gets set. So this all works, and the whole point of this is to provide you with this option. So you have options for all of the types listed here as regular nodes, like get stored int or store int, or store value for um, custom things, basically. You can totally plug an integer into this and it'll work. Um, but I wanted to have the option of more complex data structures that you can store without having to do a bunch of extra work to store them. You just plug in the structure, and then the extra work comes when you need to load the data. And I found this to be really important because I want to give you options on how you load the data instead of forcing you to do it a specific way. Although in this case, I guess I kind of am, but you have the option to decide how this data gets plugged in. And let's go to the sphere, which is very simple. On begin play, I provide some values for my test array. I wanted to make sure that the value at the index is different than the actual index itself, just to avoid confusion. Then we store that as an array, and then I can get stored int array, which is a function within the expanded save game library. Um, on on begin play, I have a delay here, so that way you can see the spawned actor before the physics state gets set and then stored. And this does store the physics state. You can also specify the spawn method if you want to. Um, and so when uh, when this actor is loaded, the physics state will also be loaded based on whatever it is for any skeletal or static mesh components. Let's go ahead and demonstrate.